Hello, everyone. My name is Marco Wolscher. I'm a PhD student at the Friedrich Schiller University Jena, and I will give you a short presentation of how StackSTAC is paving the way towards on-the-fly Sentinel-1 NRB data cubes. Just for context, in the last year, that is my colleague John Trockenbrot and I, have worked on study 1 of the COPA project by the European Space Agency, which deals with the development of a new Sentinel-1 normalized radar backscatter product. And without going into too much detail, I will just give a quick overview of this data product. You can learn more about it in the resources that I've provided here. And if you happen to be at the Living Planet Symposium next month, you can also visit one of several talks about this data product there. In short, this NRB product is a high quality analysis ready data product compliant with the Card4L NRB specification. And one goal for this NRB product is for it to be easily exploitable by users for time series analysis, for example, especially in cloud computing infrastructures. But of course, also locally on a laptop, for example, if you want, just as I am on my laptop, and I will give you a quick demonstration later on. The implementation of cloud-native geospatial data formats is a very important part. On the right-hand side, you can see an example of how the file structure of an NRB product looks like. Each product contains the main backscatter measurements and several annotation data sets. For example, the local incidence angle in Cloud Optimized GeoTIFF format. And each product also includes metadata in XML, but also in stack.json format. And with these stack.json files included in each NRB product, they can be used to create on-the-fly data cubes, as I've mentioned already. But before coming to that, users would need to create higher level stack catalog and collection files for the data set. Both are highlighted here in light gray, just as an example. And as most of you will maybe familiar with StackSTAC already, you know that it's maybe not that hard to do. So just with a few lines of Python code, you can just create these files that are necessary. I've provided an example script in the references if you're interested. And once they are created, the stack catalog file can be read with tools such as StackSTAC to finally create a data cube. And or you can also call it a 4-dimensional task-based X-array data array, but I guess that doesn't roll off the tongue quite as good. And once you have done all of that, you can play around with this data set. You can explore it. Here, for example, it is shown in a Jupyter Lab session. And as a lot of you will probably be familiar with this already, it's very interactive, so you can explore which assets of this data set are available, for example, here as bands, or which metadata fields are available that you can filter the data with and create a subset of the data set, and then finally analyze and visualize the results that you are creating in your environment. Our implementation of StackSTAC very closely aligns with the Card4L ZAR extension. And so this includes a lot of metadata fields that are related to this Card4L NRB specification that I've mentioned earlier. Here you can see just another example of this data set. You can see a bit more of what is included. There's a lot of fields that you can use. Of course, some of them are maybe not as usable in an analysis context, but they are nonetheless, they are very important to have. And a lot of them are, if you have a more complex data set, they are very, very good to have. You can do a lot of, you can do a very complex analysis if you want. And just to give a very quick demonstration, they have recorded on this laptop. So it's, you don't have to be on the cloud to do an analysis. You can download, or you can create some data sets yourself, and then just with a few lines of code, you can do some amazing things. Just as you can see here, it's a data set of 60 scenes, so it's around 60 gigabytes in total, and in just a few seconds, it's the data set is subsetted, filtered by some stack metadata fields, and then visualized interactively. And yeah, personally, I'm very motivated to explore this even further, and I'm excited for the future of cloud native geospatial. And yeah, thanks for your attention.